Hello everyone, in this video we are going to compute the 2's complement of a number using 8051 microcontroller. The first block here denotes the program memory and the next block denotes the data memory. Both of them belong to the external memory. Now I am going to use the data pointer register to point to the address location 8500H. And the assembly language program for that is MOV dptr hashtag 8500H. Now we know that there is a register present in the 8051 microcontroller called as the accumulator. Now what I'm going to do is I'm going to copy the value which is present in 8500 into accumulator register. Copy. So since the accumulator register is present inside the 8051 and we are accessing the external memory, we have to use MOVX. MOVX A, we are sending it to A at dptr. So I'm accessing at dptr at that location 8500. I'm taking the value and copying it into the accumulator. Now initially in 8500H where the dptr is pointing, there is some hexadecimal number present in it. For example, let's say 56H is present in this 8500H. Now we want to find the complement of this hexadecimal number. First, we will find the ones complement of that number. And then if we add +1 to the ones complement, we are going to get the 2's complement of that number. Now to find the ones complement, there is an instruction CPL which complements the number. So I'm going to write CPL A. Because we have stored the value of this in A, I'm going to write complement of A. Now we have to add 01H to this A. For that I'm going to use the add instruction, add A, hashtag 01H. Now this instruction is going to give us the 2's complement. But we have to display the 2's complement, right? So for that I'm going to tell increment dptr. So now after incrementing, the dptr is going to point to 8501H. Now if you observe the accumulator, you will find that it now contains the 2's complement of the original number. So we have to store this A value into 8501 where dptr is pointing. So I'm going to write MOVX because again from within 8051 we are sending it to external memory, and for that we have to use MOVX. And then I'm going to write at dptr, A. So from A it goes to the dptr location which is 8501H. 8501H has 2's complement. And now I have to halt the program, and for that I'm going to write halt sjump halt. So in this instruction it jumps back to itself and halts the program automatically. Now we will practically implement this in 8051. Before that we need to know something called the opcodes. You can refer the opcodes in the opcode sheet given to you. Now let's see what are the opcodes for the instructions we have given. So for MOV dptr it is 90. So this opcode is going to be given to 8000 memory location. And for whatever address location we are giving, we have to give the opcode for that too, 8500. If we are using 8100H, we are writing 81 and 00. This 85 is going to go to 8001. And similarly 00 is going to go to 8002. And for the next one, MOVX A, at dptr, the opcode is E0. And similarly, if you complete all the opcodes, you're going to get something like, here we have all the opcodes necessary for computing it in the 8051 microcontroller. Before that, let's take this example 56H. Take 56H and convert it into its decimal equivalent, which is 86. And once you have the decimal equivalent, convert it into its binary equivalent. When we convert the decimal equivalent of 86 into binary, we get something like 0101 0110. This is the binary equivalent. So we have got the binary equivalent. Now to find the complement, we are going to switch all the zeros to ones and ones to zeros. If we do that, we are going to get something like 1 0 1 0 and then 1 0 0 1. This is the complement, ones complement. To find the 2's complement, you just have to add 1 to this. So that will result in 1 0 1 0 1 0 1 0. This is the 2's complement. And this is the 2's complement of 56H. If you convert this into hexadecimal, you are going to get A has the hexadecimal equivalent. Now let's verify this using the 8051 microcontroller. So we go back to examine memory external data, then 8500, and then we have entered whatever 56H, and then if we click next, we will have our 2's complement which we had derived AA. So this is the experiment of 2's complement.